Let's have a ball.
Hello everyone, how are you today? I hope you're all happy and healthy. So welcome back to this learning session with me. So do you know what we are going to learn today? And what does the picture mean? A car with a speedometer? Distance? So let's study with me. I'm Desvita Putri Faza from Smart University from Faculty of Education with study number K1324026. So, today we are going to learn about a fundamental topic in mathematics, that's integration. So, can you imagine a car moving on the road? The car speedometer changing speed. Sometimes the car moves fast, sometimes slower. Well, to find out how far the car has traveled, we can use integration. Are you curious how to do it? So, to understand how to do it, let's start learning. Now, let's answer the big question. What is an integral? So, definition of integral. Integral is called to be described as the set of all antiderivatives. Simply, if you know the derivative of a function, the integral takes you back to the origin function. So we can say that integral is antiderivative. And then we know the general form of an integral. We have the integral sign which look like S, and this symbol is the operation of integration. This is general form of integral. So we know that capital Fx is equal to integral of fx dx. The process of finding f capital or capital F is called integration. Capital F is antiderivative of fx. And fx is the integrand, the function being integrated. And then dx indicate that the integration with respect to x. And then we know the types of integrals. There are two types of integrals. First, indefinite integrals. The integral has no bounds nor limits, or it doesn't include specific limits, and the result is function with a constant c. The notation is the integrals of fx is equal to capital F x or antiderivative x plus c. Next is properties of indefinite integrals. We need to understand the properties to make it easier for us to apply them. So, the properties first, the integral of fx plus gx in bracket is equal to the integral of fx plus the integral of gx. And then the integral of k times fx is equal to k times the integral of fx, where k is a constant. Let's look at the basic integration rules for indefinite integrals. So, when integrating x to the n is equal to 1 over n plus 1 times x to the n plus 1 plus c. And then, if we have a constant a multiplied by x to the n is equal to a over n plus 1 times x to the n plus 1 plus c. So, we'll understand with examples. Let's get to the example. We have the integral of 6x squared minus 2x plus 3 is equal to 6 over 2 plus 1 times x to the 2 plus 1 minus 2 over 1 plus 1 times x to the 1 plus 1 plus 3 over 0 plus 1 times x to the 0 plus 1 plus c is equal to 6 over 3 x cubed minus 2 over 2 x squared plus 3 over 1 x plus c is equal to 2 x cubed minus x squared plus 3x plus c. Next is the another types of integrals, indefinite integrals. A definite integral has specific upper and lower limits, and the result is a specific value. The result is a specific value, not a function, since we are evaluating it between 2 points. And then the notation is the integral of fx from a to b is equal to antiderivative b minus antiderivative a. Next is properties of definite integrals. There are 1, 2, 3, 4, 5. First, the integral of fx from a to b is equal to fx antiderivative x evaluated at a and b is equal to antiderivative b minus antiderivative a. And then the integral of x to the n from a to b is equal to 1 over n plus 1 times x to the n plus 1 evaluated at a and b is equal to 1 over n plus 1 times b to the n plus 1 in bracket minus 1 over n plus 1 times a to the n plus 1 in bracket. And then minus integral of fx from a to b is equal to the integral of fx from b to a. And then the integral of k times fx from a to b is equal to k times the integral of fx from a to b. And the last is the integral of fx from a to b plus the integral of fx from b to c is equal to the integral of fx from a to c. Let's get to the example. If we have the integral of fx minus 1 from 1 to 4 is equal to 4 over 1 plus 1 times x to the 1 plus 1 minus 1 over 0 plus 1 times x to the 0 plus 1 evaluated at 1 and 4 is equal to 4 over 2 x squared minus x evaluated at 1 and 4 is equal to 2x squared minus x evaluated at 1 and 4 is equal to 2 times 4 squared minus 4 in bracket minus 2 times 1 squared minus 1 in bracket is equal to 32 minus 4 in bracket minus 2 minus 1 in bracket is equal to 28 minus 1 is equal to 27. Now, let's put what we're learning to the test with a few practice problems. Number 1, the integral of 8 minus 6 in bracket times 3x plus 4 in bracket from 2 to 6. Before I explain the answers to the exercise, pause this video and work it in first. Okay, let's see the answer. We can simplify it into the integral of 3x squared minus 14x minus 24 from 2 to 6 is equal to 3 over 2 plus 1 times x to the 2 plus 1 minus 14 over 1 plus 1 times x to the 1 plus 1 minus 24x evaluated at 2 and 6 is equal to 3 over 3 x cubed minus 14 over 2 x squared minus 24x evaluated at 2 and 6 is equal to x cubed minus 7 x squared minus 24x evaluated at 2 and 6 is equal to 6 cubed minus 7 times 6 squared minus 24 times 6 in bracket minus 2 cubed minus 7 times 2 squared minus 24 times 2 in bracket is equal to negative 118 minus negative 68 is equal to minus 112. Okay, next exercise. Number 2. Given that the first derivative of the function fx is represented by f axis x is equal to 6x squared plus 2x minus 3. If the graph of the function fx is true to the point 1.4, the formula for the function fx is like before, pause this video and work on it first. Okay, let's see the answer. To find the formula for the function f(x), we need to integrate the first derivative, f accent s, x, and then use the point 1, point 4 to determine the constant of integration. So first, we integrate f accent x. Fx is the integral of sec x squared plus 2x minus 3 is equal to sec over 2 plus 1 times x to the 2 plus 1 plus 2 over 1 plus 1 times x to the 1 plus 1 minus 3x plus c is equal to sec over 3x cubed plus 2 over 2x squared minus 3x plus c. And then fx is equal to 2x cubed plus x squared plus minus 3x plus c. Remember, c is a constant. And then we have to find the value of c. Okay, we can use the point 1.4 to find c. Since the graph is to 1.4, and then we know that f1 is equal 4. And then we can substitute to the fx. So 4 equals 2 times 1 cubed plus 1 squared minus 3 times 1 plus c. 4 equals 2 plus 1 minus 3 plus c. So we know that the c is equal to 4. And then the formula for the function fx is equal to 2x cubed plus x squared minus 3x plus 4. Okay, next exercise this is the last exercise, number 3. A car moved with a velocity v(t) is equal to t squared plus 8t meter per second. If at t equals 2 seconds, the distance traveled by car is s equals 20 meters. Find the formula for the distance is s as a function of the time t. This is similar to question number 2. Pause this video and work on it first. Okay, let's see the answer. To find the formula for the distance s at the time t, we need to integrate the velocity function vt, as velocity is the derivative of distance with respect to the time. First, integrate vt is equal to ct squared plus 8t to find st. So, st is equal to the integral of ct squared plus 8t and is equal to sec over 2 plus 1 times t to the 2 plus 1 plus 8 over 1 plus 1 times t to the 1 plus 1 plus c is equal to sec over 3 times q plus 8 over 2 t squared plus c is equal to 2t cubed plus 4t squared plus c. Remember, c is a constant. We have to find the value of c. Okay, next, use the initial condition x2 equals 20 to find c. So we can subtract to the function st. So we know 20 equals 2 times 2 cubed plus 4 times 2 squared plus c. 20 is equal to 16 plus 16 plus c. 20 equals 32 plus c. And then the c is equal to minus 12. So the formula for the distance s at the time t, st is equal to 2t cubed plus 4t squared minus 12. Okay guys, that's all about integration. I hope that make integral a bit easier to understand for you. If you have any question, feel free to write them in the comment section. And I'm sorry if there were any mistake in my presentation. Thanks for your attention and see you to the next learning session.